In this video, we're going to discuss how you can graph quadratic equations, how you can graph parabolas. We're going to look at 3 different ways that you can graph it. The first method we're going to use is more or less guess and check. Let's start with an equation. Y is equal to x squared plus 6x minus 2. And to use this method, basically guess and check, we're going to choose a few values of x, see what the corresponding y values are, and then just graph those points and see what our parabola looks like. It's usually easiest to choose the x values -3, -2, -1, 0, 1, 2, 3, or if you want to have fewer values, you could choose -2, -1, 0, 1, 2, because then you know that you get some positive values, some negative values, and you get 0. So our equation is x squared plus 6x minus 2 is equal to y. And what we're going to do is we're going to plug in each of these x values into the equation and see what we get for y. First x value is -3, so -3 squared plus 6 times -3 minus 2. And the easiest way to solve this is to just punch the whole string of numbers into the calculator. And so -3 squared plus 6 times -3 minus 2, and then enter, that's -11. And then you do the same thing for -2. You're going to do -2 squared plus 6 times -2 minus 2, and punch the whole thing into the calculator. That's -10. And you're going to do the same thing for -1, -1 squared plus 6 times -1 minus 2. Now I'm just going to speed this up because it's going to take way too long if I write out each of them. So I'm going to just do it quickly and I'll write down the y values. Okay, now we have all of our coordinates. We have -3, -11, -2, -10, -1, -7, 0, -2, 1, 5, 2, 14, and 3, 25. Now we can start to actually graph these coordinates. Most of the time, your maximum y value will be 10, your maximum x value will be 10, your minimum y value will be -10, and your minimum x value will also be -10. So our first coordinate, -3, -11, wouldn't be so useful to us in this situation. And our last 2 coordinates, 2, 14, and 3, 25, wouldn't either be so useful. So let's start with -2, -10. So we're going to go to -2 and down to -10. It's over here. The next one is -1, -7. So -1, -7. Next is 0, -2. That's over here. Next we have 1, 5. So that's all we have. We only have part of our parabola. You could tell that it goes something like that. And in this situation, our vertex will be cut off, even if we continue going. But let's continue going to see if we can get some values over here to continue drawing the graph like that. So we're going to need to find some more negative x values. Let's do -6. If we plug in -6, we're going to do the same thing. -6 and then -6 squared plus 6 times -6 minus 2. And on the calculator, -6 squared plus 6 times -6 minus 2. Enter. -2. So let's graph this. We have -6, so 1, 2, 3, 4, 5, 6, 1, 2. We have one coordinate over there. Let's try -5. -5 squared plus 6 times -5 minus 2. Enter. That's -7. So let's graph that. And now we can sort of start to connect our points. Our vertex will be off of this graph. And let's just see what -7 would be, so we can continue it going up. We have -7, 5. So let's graph that. And let's connect it. So our parabola would look something like this, and of course it would keep on going on forever. Usually on the Regent you'll have one where the vertex will be on the graph. In this case it got cut off because it's further down than y is equal to -10. But this is the guess and check method. You start with a few values for x, you plug them in, you find a few values for y, and then if you need to keep on going to find some more values for y, you can, and you just keep on plugging in more values where you think the graph will continue. Let's look at another method that's more likely to get you accurate values without having to plug in so many x values. Using this method, we're going to find the important values that we need to graph it. We're going to find the x-intercepts and the vertex. So had we found just the x-intercept and the vertex of this graph, we would have been able to graph with just 3 points, we would have been able to graph this whole area. So let's look at a different example. Let's say we have the equation y is equal to x squared plus x minus 6. And we're going to find the two zeros, the two x-intercepts, and the vertex, and graph those 3 points. So to find the zeros, to find the x-intercept, we always want to set y equal to 0. So 0 is equal to x squared plus x minus 6. And let's solve this using factoring. So we're going to find factors of -6 that add up to +1. Factors of -6 are 1 and -6, -1 and +6, 2 and -3, or -2 and +3. The factors that add up to +1 are -2 and +3. So our two factors are x minus 2 times x plus 3, and we're going to solve each of these for 0. X minus 2 is equal to 0, and x plus 3 is equal to 0. Plus 2, x is equal to 2. This is one root. Minus 3 and minus 3. X is equal to -3. This is the other root. So let's graph these 2 points. The 2 points are 2, 0 and -3, 0. 2, 0 is over here. -3, 0 is over here. Now let's find the vertex. Whenever we're finding the vertex, the x-coordinate of the vertex is x is equal to -b over 2a. b in this case is +1, so we have -1 over 2 times a, which in this case is also +1. So our the x-coordinate of our vertex is -1 over 2. Now to find the y-coordinate of the vertex, we're going to plug in this x value. Y is equal to -1 over 2 squared plus -1 over 2 minus 6. And let's just solve this whole thing on the calculator. Negative alpha y equals, enter to get a fraction, 1 over 2 squared plus negative alpha y equals, enter, 1 over 2, close parentheses, minus 6, enter, -25 over 4. And for graphing purposes, we're going to try to get this into a decimal. So we're going to copy it to the next line by highlighting and pressing enter, then math, down to dec for decimal, and press enter. This is -6.25. So the coordinates of our vertex are -0.5 or -0.5, comma, -6.25. So let's graph this. -0.5 is over here. Then we're going down to -6.25, so that's somewhere right over here. Now we have an accurate graph of our parabola with just 3 points. There is one more way that you can graph parabolas, and with doing very minimal work, this is probably the easiest way, and that is to graph it on your calculator and look at the table by going to second graph, looking at the table, seeing what the calculator found for the y values. Let's look at an example. Let's say we wanted to graph the equation y is equal to -x squared minus 3x minus 1. What we can do is we're going to graph it on the calculator and y equals -x squared minus 3x minus 1. And let's press zoom 6 to see it in zoom standard because the graph on our paper is also 10 by 10 by 10 by 10. There we see our parabola. But how does that help us? Because we need to know the coordinates to actually graph it on our graph on the paper. What we're going to do is we're going to press second. Whenever we press that second button, we're activating the little blue words on top of each button. So if we press graph, we're really in the table. And here we see a table of x values and their corresponding y values. We can choose the ones that are going to show up on our graph. So -5, -11 will not show up on our graph because our graph, the minimum y value is only 10. But the next one down, -4, -5, that one's going to help us. So let's make a table. We have -4 and -5. And then keep on going down. We have -3 and -1, that's going to help us. And then down more. -2 and +1. And again, we have -1 and +1. And then after that, we have 0 and -1. After that, we have 1 and -5. And then we have 2 and -11. That doesn't help us again because we don't have a -11 on our graph. But now we have 1, 2, 3, 4, 5, 6 sets of coordinates to graph very easily without doing any work. Let's graph them. -4, -5. That's over here. -3, -1 is over here. -2, +1 is over here. -1, +1 is over here. 0, -1 is over here. And 1, -5 is over here. Now all we have to do is connect these points. Something like that. Make arrows, and this is our parabola with very minimal effort. Just punching the equation into the calculator and looking at the table that the calculator made for us.